We're all pretty blown away by what AI can do, but we hardly ever stop to think about its fuel, our data. And for the new AI system we're building here at Automate, that fuel is some of our most sensitive information. So the billion-dollar question is, how do we build a fortress around that data? Well, to figure that out, let's follow one single piece of information on its journey through our entire system. So here at Automate Corporation, we are building an absolutely revolutionary AI. I mean, this thing is designed to streamline our entire business. It's going to be analyzing customer emails, sifting through confidential internal documents, processing transaction logs, you name it. It is a total game changer, but that also makes it a huge magnet for our most critical data.
And that leads us right to the central challenge, doesn't it? This amazing AI is powered by our company's most valuable, most secret information. If that data gets exposed, or worse, manipulated, the fallout could be catastrophic. So how exactly are we building that fortress?
We're going to do it by tracking a single customer query from the very beginning to the very end. This way, we can see exactly where the vulnerabilities lie, and, more importantly, how we've engineered our defenses to lock it down at every single step of its journey. Okay, so our data's journey kicks off the second it's sent. This first stage is all about one thing: protecting it while it's in transit, while it's on the move from one place to another. So what exactly do we mean by data in transit? Well, it's any information that is actively moving across a network. The best way to think about it is like a valuable package being sent across the country in an armored truck. The moment it leaves the building, it's out in the open and it's vulnerable. And in our AI system, this is happening constantly. Let me walk you through a typical path. A customer sends a prompt to our AI. That data zips across the public internet, it hits our digital front door, that's the API gateway, and then it gets passed along to the AI model itself. Then the AI sends a response all the way back. Every single one of those hops is a potential point for someone to try and intercept it. And you can really see the difference here. Without protection, that data is basically in a glass box. Anyone in the middle can read it, they can steal it, or they could even change it. That's exactly how an attacker could tamper with a user's prompt to make our AI do something malicious. But with modern encryption, something like TLS 1.3, we put that package inside that locked armored truck. The data is completely scrambled, and both sides have to prove who they are before the lock ever gets opened. So this is the key, right? By securing data while it's on the move, we completely shut down an entire category of attacks. Eavesdroppers can't read the prompts, attackers can't inject their own malicious commands. It's the first, most fundamental layer of our AI fortress, but it's only the first link in a much longer chain. All right, our data package has arrived safely at its destination. The armored truck made it. But the journey isn't over yet. Now it needs to go into the vault. This stage is all about securing data at rest. Data at rest is pretty much what it sounds like. It's information that's been stored somewhere. We're talking about our massive training data sets, the AI model files themselves, and all of the system logs and backups. So if data in transit is the package in the armored truck, data at rest is that same package locked away inside a high-security bank vault. And this is why that vault is so absolutely essential. Our stored AI data is a literal treasure trove for attackers. It's got personal information from our training data, sure, but it also contains the AI's brain, the model weights. That's priceless intellectual property. Even these things called vector embeddings, which is how the AI turns concepts into numbers, can sometimes be reverse engineered to reveal the original sensitive info. So how do we build this digital Fort Knox? The gold standard in the industry is an encryption algorithm called AES 256. To give you some perspective on how strong this is, it would take the most powerful supercomputers on Earth literally billions of years to break it. This is the lock on our vault. What this means is, by encrypting everything at rest, we neutralize another set of critical threats. Even if an attacker somehow broke into a data center and physically stole a hard drive, all they'd have is unreadable gibberish. Model theft, training data leakage, all of it is stopped cold. And just like that, the second link in our security chain is secure. So our data is secure on the move, and it's secure in storage. But what happens when the AI actually needs to use it? This brings us to the final, and frankly, the most complex stage: protecting data while it's in use. So data in use is data that's been pulled into a system's active memory, its RAM, or the VRAM on a powerful graphics card, so the AI can actually work with it. To stick with our analogy, this is the moment we take the package out of the vault, bring it into a top-secret sealed room, and finally open it up to see what's inside. And this right here is why this stage is so incredibly important. A lot of cybersecurity experts will tell you this is often the weakest link in the entire security chain. It is the moment of maximum exposure. So why is it so dangerous? Well, because traditionally, for a computer to process data, it has to be decrypted. For just a brief moment, that sensitive customer query, those secret model weights, it all exists in plain text inside the computer's memory. A sophisticated attacker or a malicious insider could potentially peek into that memory and steal the data right as it's being used. So how in the world do we protect that secret room? The answer is a truly groundbreaking technology called confidential computing. It lets us create a hardware-isolated bubble, a secure enclave. Think of it like a special processing room where even the computer's own operator can't see what's happening inside. The data is decrypted, processed, and then re-encrypted, all completely within this protected space. The impact of this is huge. This technology is how we stop a whole new class of very advanced attacks. It prevents data from being scraped from memory. It protects us against attacks in shared cloud environments where you might be on the same hardware as other customers. And it even helps reduce the risk of insider misuse. It's a real game changer. Okay, so now let's take a step back and see how these three pieces, in transit, at rest, and in use, all fit together to form one complete security shield for our AI. This table really lays it all out, doesn't it? We protected our data in transit with encryption like TLS, which stops network-level attacks. We secured it at rest with AES 256, protecting our storage from being physically stolen. And we guarded it in use with confidential computing, shielding it during that critical moment of processing. You see, each state protects against a completely different set of risks. And this right here is maybe the single most important takeaway. These three layers aren't just optional extras. They are a mandatory, interconnected chain of security. Strong encryption in transit doesn't matter one bit if your stored data is unencrypted. And securing your storage is totally useless if an attacker can just scrape that same data from memory while it's being used. This framework gives us a really robust defense for the AI systems we have today. But it also leaves us with a critical question for tomorrow. As these AI models become exponentially more powerful and woven into the very fabric of our lives, how are we going to have to evolve these defenses to stay one step ahead? Now, the strategies we've discussed today aren't just theories. They're grounded in leading industry frameworks from organizations like NIST, OASP, and ISO. These are the very standards that are shaping the future of secure AI. The journey to protect our data is an ongoing one, and it's a journey we all have a stake in. Thanks for joining us on this explainer.